Hi, Janvi Kodogu. How are you? Kodogu. Whether you people are from whole school or only person, you keep a name like that. Just a minute. Give me a second. Screen share has stopped. Share the window close. Fine, sir. Okay, just 2 minutes, guys. Okay, welcome to all, guys. Is chemistry class finished? Is it finished? Yes, I'm fine. Thank you. I'm fine. I'm fine. There are two accounts, JNV Kodogu, JNV Kodogu. May I know whether you people are logging from school or else you people log in from your mobile as a name of Kodogu? From home. Then good. It's fine. Hi Komal. Hi Yashaswini. Hi Ananya. Hi, hello. How was the day? I'm fine. I'm fine. How Ananya? How are you? Guys, you people only keep the name as a Kodagu, and you people are fighting here in a chat box. Who is that Kodagu? Huh? So funny, yaar. Good evening, Yashaswini. Good evening, Prakriti. Good evening, Preeti. Good evening, everyone. Still only 12 members, including me. Okay. We'll wait for the 2 minutes, guys. Okay. Then good evening, Ananya. We'll start. That's good. And meanwhile, if you have any doubt, means please ask me the doubt. Okay. I'll try to reach out to you. Good evening, Sridevi. Good evening, Swati. Good evening, everyone. Good evening, Nandini. Why you people are watching in YouTube? You people don't have a school ID? Rudra? Those who are watching in YouTube, no. You people doesn't have any school ID to log into the Zoom. Good evening. How many Kodagu accounts are there? Hey, what you people are doing? Huh? Okay, guys, we'll start our today's session and welcome to all of you here. Good evening, Purva. Okay, and today in this class, we are going to discussing about a few important properties of electric field lines and as well as the problems also, numericals also. ये दोनों को properties and numericals, okay, not intensity. And before starting, guys, let us take a quick recap. Sir ask the name. Hey, no, you people discuss that one. I'm not download Zoom, sir. Okay, Nandini, cool, koi problem nahi. Okay, we'll take a quick recap what we discussed in the previous classes. In last class we started the electric field intensity or electric field. इलेक्ट्रिक फील्ड जनरली क्या होता है, देयर इज अ फील्ड व्हिच इज अराउंड अ चार्ज. चार्ज के अगल बगल क्या होता है, एक फील्ड रेज्यूम होता है, उसको हम कहते हैं इलेक्ट्रिक फील्ड. करेक्ट ना. इफ एनी अनदर चार्ज विल बी कम इनटू दैट फील्ड मींस it feels some force due to that charge force. Correct now. Let us discuss furthermore. And if any positive charge is there means the electric field lines, actually these are the imaginary field lines which are emerging out radially. Okay, emerging radially outward direction. If any negative charge is there means it will be, the field lines will be acting towards it. This is negative charge, this is positive charge wala. Okay, then next we talked about the electric field lines. If two charges will be present means how the field lines will be executed in a space we need to study. One positive charge tha and the next one another one negative charge tha, right? If positive charge negative charge kept nearly means not isolated charge, I'm explaining. If only isolated charge is there means this charge is not there means, okay, then the field lines will be moving in a space outward up to infinity. Okay, if any another charge is there means field lines will be started from the positive charge and ends at negative charge, right? And then if you want to find out the electric field direction means I will explain this one today. Okay, at any point in which point you want to find out the direction of electric field line, at that point try to draw one tangential. Okay, it will give the direction of electric field. Clear now? This is the region which is around the two charges. Okay, if I have to take the two positive charges means actually these two charges ke wajah se actually they are repelling, right? The electric force will be happens like this. These field lines you might be observe here, these field lines are not actually interacting like this, they are actually pushing like this. That's why two charges will be always repel each other, like charges especially. Clear na? And then strength. Electric field strength क्या होता है? Electric field strength, I told you that if any charge in this region, मान लो this is the region, this is a charge, this is the electric field lines. Here any test charge will come means it experience some force due to this source charge. Correct now? That is known as the electric field strength. We will define this one mathematically. Force acting per unit charge. कौन सा unit charge? Unit charge के ऊपर कितना force act हो रहा है, that will tell the electric field strength. Okay, and then electric field strength का positive charge होता तो direction क्या होता है? Actually I told you that force in which direction it will be act, in the same direction electric field intensity will be act. Correct now? If positive charge is there, we'll take on test charge Q naught. Positive charge से electric field lines away from the charge होता है ना, from this charge only away होता है, means in this direction, right? Force acting on the test charge will be in the same direction and electric field direction also same. If it is negative charge means towards the negative charge force will be act, okay, on the test charge, hence electric field direction also towards it. And if you want to find write the value in a vector form means just multiply with the r cap. Okay, r cap will give the unit vector, we call this one as an unit vector, and it will give the exact direction also. Unit vector also guys, actually r we are representing unit vector means इसका value होता है, मैथ्स में पढ़ाता है ना आप, x, y, z, r को generalized form में Cartesian coordinates. Correct? Along the x axis also we can define, along the y, along the z, three axis also we can define this one. Okay, and then source charge also produce the electric field, but the presence of this test charge also produce the electric field, but the presence of the source charge, the test charge electric field value will not greater. That's why always we are treating source charge, sorry, test charge, electric field will be 0. Cool. Okay. Then next note points हुआ था, कुछ problem नहीं. And SI unit can be written as Newton per Coulomb. Dimensional formula also we did. And this is a vector format actually, guys. देखो इधर positive charge इधर है. This is a point charge. Or else just assume that this is a point which is in a free space. Free space. At this point, if you want to find out the electric field intensity, means draw a vector up to that point. Okay. On that Q naught, ये टेस्ट चार्ज है ना, इसके ऊपर फोर्स एक्ट कर रहा है प्लस Q से. दिस इज अ सोर्स चार्ज, दिस इज टेस्ट चार्ज, राइट, along the line joining point, and distance will be r. It can be expressed along x comma y comma z. That's it. कुछ है ना? नहीं. Next thing, electric field strength. We explained that force per unit charge, and it's a vector format. We done. Okay. And yes, if the distance will be increases from the charge, means the field intensity also keep on decreases. Okay. देखो, this is charge, means charge के अगल बगल. If you're going to consider this the area, means in this area बहुत सारे field lines है. That's why at this point, if I keep any one charge, means okay, at this point, guys, at this point, if I keep any one charge, means it will feel more force, right? If I put another charge at this point, कौन सा point? थोड़ा दूर में रखता हूं मैंने इधर. It will not, this second charge will not feel that much of force due to this test source charge, because as the distance increases, field intensity also decreases. That one we need to show in a graphical method. If you draw that graph, means it will be exponentially decreasing order. We will get parabolic path. Correct now? And then yeah, spherical symmetric hota hai. I will explain this one later. Okay. Up to this point, guys. Up to this point, is there any doubt for anyone? Let me know in a chat box quickly. Is there any doubt? Good, Yashaswini. Please do participate in chat box, yaar. And those who are watching in YouTube, no, please drop your words in our chat box. No doubt. Good, Sagar. Good, bro. Cool. Good, Vishal. Okay. If you don't have this, okay, let me know what is the correct answer for this question. I will tell you what is the question first. 5-point charges. There are 5-point charges. Each value Q plus Q are placed on 5 vertices of a regular hexagonal side L. This is a regular hexagon. Charges are 2, 3, 4, 5. Each side is L. What is the magnitude of the force on the charge minus Q, which is placed at the center of the hexagonal? Yes, here at the center there is a minus charge. What will be the force experienced by this charge, minus charge, due to this all the forces? They are asking. Let me know the correct answer through the chat box. Solve it and tell me. It's very simple. I will check who will give the correct answer first. Right, Yashaswini. Good. Good, Srujan. Only 2 members give an answer. Good, Jansi. Right? Jansi, once you check it, cross check it, sorry. Purva, check it once. Check it, check it. Yes, Devegowda, right? Sagar, no. How it will become? No, bro. Guys, look at here. In hexagonal, hexagonal, here this distance also will become L only. Length will be L only for the center. Correct now? L only the length. Same length will become. Okay. This is the first charge. Applies the force on E minus Q means in which direction it will be applies? Towards the charge or away from the charge? On this charge it is applying. That's why away. This fourth charge also diagonally opposite end. Correct now? That's why this charge applies the force on the negative charge in this direction. And charge value, magnitude of the charge. A charge ka magnitude. Arey yaar. Why this page is not supporting properly? I don't know. Okay. Magnitude of this charge. Okay. And this one magnitude will be equal. Hence, the force will be equal on the minus Q charge, which is placed at the center, but opposite direction. Hence, these two charges forces will be 0. Clear now? And then coming to the next diagonal. Here one charge is there, here one charge. Similarly, these two charges applies the force on the negative charge, which is kept at the center. Kept at the center. Again, equal and opposite direction. These two will be cancelled. And remaining only one force will be executed on this negative charge from the Q3. Means this charge. Okay. This charge say force apply hota hai. Because in opposite diagonal mein no charge is there, no. Correct? Hence, if you're going to write the equation for this one means force, how we will write? General equation. Force is equal to K. Dono charge means here Q, both are. We are not taking sign here actually. And divided by R square means L square. Means we can write this one K Q square divided by L square. Means correct option A. Right, guys. So many of you are given a correct answer. Let me know those who are not yet given an answer to this question. No, is it understood, right? Is it understood? Yes, Srishti, right. Is it understood, right, for everyone? Or else is there any doubt? Yes, Jansi, good. Arey yaar, please do participate, yaar. Chat box le draw. Do tell me something in a chat box. Thank you. Good. Next thing, very interesting factor and good one. Charge density. आपको density पता है ना? Okay, density क्या होता है? What is the meaning of density? Tell me in a chat box. How we will define density? General density. I'm not asking any charge wala either. Mass by volume. Yes, right, everyone. Okay, means if I consider this is a cube, okay. इसके अंदर for this volume, how much inside this volume, how much mass is present? Correct now? That mass over this volume will give the density. Mass over volume, right? This is we studied in mechanics. Means last first chapter, I think second chapter only they will give the introduction of density. 11th May. Yes, right, everyone. Okay. Here similarly, I told you that whatever the mass we are considering there in 11th standard, we are considering here charge. Correct now? That's why we need to replace that one with respect to the charge. मान लो first one linear charge density is there. Linear charge density means charges will be actually segregated on a linear portion of any substance. Here one rod is there. मान लो on the surface of a rod I distributed positive charges. Okay, इसका लेंथ था L. ये पूरा का पूरा चार्ज है ना, वो टोटल चार्ज Q है. Q plus Q. Okay, here linear charge density means same mass by volume बोलते थे ना आप उधर. Either also we need to tell that charge per unit length. Charge per unit length, not volume here. First, linear means only lengthwise we need to calculate. Charge per unit length. And linear charge density is represented by lambda. Okay, this is the equation for linear charge density. Clear? Come to the next one. surface charge density. Surface charge density क्या होता है? Actually surface means area, should be having some area. Now you might be know here in second figure, if I distribute the same amount of charges on this surface here, means now the total charges will be present here, plus q charges in the unit area, means length into length, here दोनों same ले लो, कोई problem नहीं, correct ना? Here charge distributed over the area. Now we need to define the density, means again we need to define like this: charge per unit area. Charge per unit area. It is represented with the letter sigma. Sigma tells the surface charge density. Lambda linear charge density, sigma surface charge density, right? And coming to the third one, right? We'll move to the third one. Third one में पूरा बॉक्स है, बॉक्स के अंदर हमको भरना है चार्ज को, ओके? भर दिया मैंने, देखो पूरा हो रहा है, right? These are all the charges which I am going to fill inside the volume of this box. Now the charge density can be defined as पूरा प्लस चार्ज है, okay? Charge per unit volume. This is actually represented with the letter rho. Rho stands for here volume charge density. Okay, these are the three equations. Just for the sake you need to know. Clear, right? Yes, right. Right, everyone. So then right, bro. Yashaswini, right. Right, Amma. Is there any doubt regarding about this charge density? Same mass density कैसे बोलते थे ना आप? In a similar way we need to define this one. Okay, how many of you understood? Okay, few people are responding. Good. Actually I think from my end there is an internet issue. ये मैसेज स्लो आ रहा है, कोई प्रॉब्लम नहीं. Thank you Purva. Thank you Jansi. Right, good. Yes, Rami Naidu. Clear. Good. Good guys. Okay, if it is clear means again we have a good question. आपको बोर नहीं लगना है ना, इसलिए मैंने आज बहुत सारे प्रॉब्लम लेके आ गया हमने. क्लियर ना? फर्स्ट प्रॉब्लम के अंदर क्या क्या है देखते हैं. What is the magnitude of a point charge due to when electric field is 30 centimeter away has the magnitude of 2 Newton per coulomb? Here what they are asking actually, what is the magnitude of point charge? Okay, okay, okay. देखो इधर एक पॉइंट है, ओके? एक पॉइंट के ऊपर इलेक्ट्रिक फील्ड इंटेंसिटी, हाँ, ओके, न्यूटन पर कूलम मींस इलेक्ट्रिक फील्ड इंटेंसिटी, राइट? ऑन दिस पॉइंट इलेक्ट्रिक फील्ड इंटेंसिटी फील हो रहा है कितना? 2 न्यूटन per coulomb. At a distance, they told the distance also, at a distance 30 centimeter. Means here electric field intensity का feel हो रहा है, means इधर कुछ होना चाहिए ना, चार्ज वगैरह होता है. They are asking that इधर एक चार्ज है, उसका मैग्नीट्यूड कितना है बोलो. They are asking to find out the magnitude, how much coulomb it is. Clear, right? Try to solve this problem. Simple सा है, हल्का सा प्रॉब्लम. ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕು ಅಂದ್ರೆ ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ, ಈಸಿ ಕೂಡ ಇದೆ. electric field intensity find out ಮಾಡಲಿಕ್ಕೆ ಫಾರ್ಮುಲಾ E is equal to F upon Q. E is correct. Sustri, right. Excellent. Right, but इधर Q naught है, Q naught कुछ नहीं है इधर, right? Actually electric field intensity doesn't depend on the Q naught. टेस्ट चार्ज ही नहीं है, पॉइंट के ऊपर पूछ रहा है. That's it. Means we need to again substitute something here. That is F value क्या होता है? K Q and then Q naught divided by R square, इधर Q naught. Second formula. How we define? No, that one. Q naught cancel होता है. Then electric field strength or intensity will be equal to K Q upon R square. This is a simple formula. Just I solved again. Clear now? Yes, right, Nandini. Right, Vishal. right Vishal? Good Apeksha. Okay, k value आपको पता है, already they given some few values. We need to calculate here magnitude of charge means q value को पता करना है. Then substitute the remaining thing. E value they given no. How much they given E value? 2. Correct ना? 2 Newton per coulomb. Good. And k value आप हमको पता है. K value guys, if they are not giving means try to use this formula word. K is equal to 9 into 10 to the power of plus 9. Okay, this is the magnitude of value of k. Substitute here 2 into 10 to the power of 9 into q value which we have to find out here divided by r square. R square का value दे दिया है 30 सेंटीमीटर. लिख दो इधर 30 सेंटीमीटर. q is required, right? Take 30 centimeter to left hand side. Is this color is okay, right? Is it visible? Blue color, is it visible? Yes, okay. 30 सेंटीमीटर इधर लेते हैं मैंने. Then 2 into 30, this is square. Printing mistake, okay? Square है. Don't forget this one. Into 10 to the power of minus 2 whole square. We can write like this. Means meter को convert करना है इसलिए. Is equal to right hand side में again this is 9. Okay, 9 into 10 to the power of 9 into q. Clear now? Take 9 to left hand side again. Then it will become, why I don't have to write, 2 into 30 square means it will be 900 into 10 to the power of minus 4. Then taking 9 means it will comes to denominator. 9 into 10 to the power of 9 is equal to q. Right Ashwini, right answer. Right answer. Clear now up to this point? नेक्स्ट क्या करता हूं मैंने, देखो इधर q is equal to इधर 900 है. ओके, 2 into I will write this 900 as a 9 into 100. Right Srujan, right Srujan. 9 into 100 means 10 to the power of 2. I split this one, I write like that. Okay, and then into remaining क्या है, कुछ नहीं, 10 to the power of minus 4. Why is if problem solving is not inconvenient, if you are not connect properly means tell me, I will explain again. Okay, this is actually 900 था ना, 900 को मैंने split करके लिख दिया. 9 into 100, 900. 100 को 10 square कर दिया मैंने. 10 square is nothing but 100 only, and into 10 to the power of minus 4 will be stay there itself. In denominator 9 into 10 to the power of 9 is there. This 9 will be get cancelled. And in numerator देखो क्या क्या बचा हुआ. This is base are same. Add these two index. Okay, add करने की वजह से आपको मिलता है 2 into 10 to the power of minus 2. Here plus 9 is there. If it is comes to numerator means 10 to the power of minus 9 होता है. Hence q value will be comes to be 2 into 10 to the power of minus 11 coulomb. Means exactly right. Everyone solved. I'm really happy for this one. Those who are solved, no, they are giving answer in the chat box. It gives a alag level of confidence me to me. Good, good Hemant, right. Hope you all understood also how I solved. Okay, now it's good. Okay, well, we'll move to the next concept. इधर concept के साथ थोड़ा समझने का भी चीज है. Okay, concepts क्या है देखो इधर. No point charge produce electric field at its own position. At its own position means मान लो this is charge plus q charge. Okay, we are saying like that electric field will be emerged from the point charge. Means from this point charge, the electric field lines will be emerging like this in all the direction. Okay, here they're saying electric field at one position. One position means center में, at the center there is no electric field. A charge के center में electric field value will be 0. Clear? First point. Second point, since in a simple word you may also note down, it is better. Okay, at the center of the charge, no electric field lines. Second point, since charge is given to a conductor, resides on the surface, hence electric field inside will be 0. If you're going to charge any conductor, charging method बोल दिया था ना मैंने, during that time charge होता है body means all the charges will be present on the surface of the conductor. They will resides means they will occupy on the surface only. Inside the electric field क्या होता है? 0. Electric field will be inside 0. Why 0? I will tell you in the next class. We will do 1-2 problems, then you will get an idea about it. If it is regular shape means symmetrical ऐसे arrange होता है. If the body shape will not regular means the arrangement will be like this. Okay, and there might be where the sharp corners होता है ना, sharp corners of the body, at that point charge leakage भी हो सकता है. Charge leakage. Clear? And next, coming to the point, the electric field on the surface of a conductor is directly proportional to the surface charge density at the point. That is, electric field value will be directly proportional to the surface charge density. मान लो this is a conductor, एक conductor के वजह से at this point some electric field will become correct ना. This electric field value magnitude है ना, it is actually depending upon the charge density. Means either मान लो 20 charges are there. Okay, electric field you will get around 20. Just example I'm giving. 20 coulomb of charges are there. That's why you will get here 20 Newton per coulomb electric field intensity at this P point. If I'm going to raise this one to 30 coulomb, 30 charges if I'm going to accumulate on this surface means here the value also again increases. Means this electric field intensity value actually depending upon the charges which are accumulated on the surface. That is the third point. Simple word hai. And next word, two charged spheres having radius r1 and r2, charge density ρ1 and ρ2 respectively. Then the ratio of electric field on their surface will be कैसे depend होता है देखो इधर density directly no, now only I told it is depending upon directly, but for the radius they are inversely dependent. कैसे होता है देखो इधर surface charge density sigma is equal to charge divided by area, correct ना. Here क्या what they took actually, this is a question guys, be careful. These are the two spheres, correct ना. Two spheres में surface area क्या होता है बोलो इन चार्ट बॉक्स में. Surface area of the sphere, surface area, are you there? Hello, am I audible, right? What is the surface area? अरे यार sorry, now check it once. I will explain again, check it once. Yes. Okay, actually sigma 1 by sigma 2 is there? No, sigma 1 means here q by charge. So charge by area. Charge by area means 4 pi r square, right? R, if I am taking first circle means r1 square I will write. For this second one sigma 2 ke liye, again if I am writing means again it will become q by surface area. Area will comes to numerator. That time r2 square we can write. Here everything will be cancelled, remaining will be r2 square by r1 square. This is how they might be asked the question, how the radius of the sphere which are proportional to the charge density, surface charge density. Not audible, guys, check it. Swati, check karo ek baar. Am I audible, right, guys? Swati, check karo ek baar. Cool. Yes, thank you, guys. Okay, here electric field intensity E1 by E2, it is directly proportional to charge density sigma 1 by sigma 2, but it is inversely proportional to the square, means inversely proportional to the radius of the circle, square of the radius of the circle. Yes, good, good. Okay, ma'am. Hope it is clear. And then move to the next concept. इधर एक concept है देखो, a small ball is suspended in a uniform electric field. Uniform electric field है इधर, मैं बनाता हूँ इधर देखो, this is uniform electric field मान लो. Okay, this ball is actually suspended there, right, with the help of insulating thread. This is an insulating thread. If high energy X-ray beam falls on the falls on the ball, look at here, this then X-ray will come and fall on the ball. Okay, X-ray knocks out the electron from the ball, and so the ball positively charged, and therefore the ball is deflected in the direction of electric field. Simple है, simple क्या है ना, देखो इधर एक electron है, क्या है इधर, electron है. If electric field, if I am going to apply in this direction, means this is the electric field direction. Okay, here they are talking about ball only, right? Ball is positively charged. Sorry, मान लो this is a positive charge. This is electric field lines. Okay, if I am going to apply any force on the positively charged electron, means proton के ऊपर थोड़ा force लगाना है से, क्या होता है, थोड़ा सा, that's it. It will move in the direction of electric field. Movement किधर होता है, electric field के direction में होता है. If it is positive charge, if it is positive charge means moves along the electric field. If it is negative charge means क्या होता है, moves opposite to the electric field. Keep this point in your mind. लिख दो इसको. If electron, sorry, if charge is negative, then it move against the electric field, against the electric field. Simple सा concept. Clear na? Guys, everybody is leaving the class. I don't know why. Okay, please stay in the class, and meanwhile do participate in this poll also. Okay, please do participate in this poll also. If I'm taking your 1 hour time means I would like to be worthy for that one, right? If you people are living in between a session means how it is good, right? Okay, कोई problem नहीं. We'll come to the third point. Those who are actually participating NPS, no, after participating, come to the class here. Okay, for next point is that electric field lines always directed from the higher potential to lower potential. Similar way, energy is always be moving from higher potential to lower potential. No, in a similar way, here charge is there means from charge only electric field lines will be move, means here only potential is high. Potential high is at near the charge. From this point is higher potential, that's why this field lines will be moved away from the charge like this. Okay, next, a positive charge if left free in an electric field always moves from higher potential to lower potential, while a negative charge moves from lower potential to higher potential. I told you that this one here itself. If a positive charge is there, means it will be moving from, like, electric field, in which direction it is there? In this figure, in this figure, in this figure, in this direction electric field is there, electric field. Okay, means higher potential is here, that's why electric field will be in this direction, that's why positive charge also move in this direction, right? But electron kya karta hai, towards the higher potential it will be moved. This is also concept. Sir, if charges will be neutral, will not move when force is applied. Exactly right, good answer, good question. If charge is neutral means, I think no, but I will give the answer by the end of the class. By the end of the class, once I will check and I will give the answer. Okay, your question is like that. On a neutral charge, is there any force will be experienced by the test charge, right? I will give the answer by the end of the class. Okay, I will search and I will explain you. Okay, and then come to the point. Yes, we'll explain this one today. Okay, we'll explain this one. थोड़ा सा प्रॉब्लम भी है इधर इसके अंदर and concept भी है, इसलिए find the electric field intensity at a distance A from the continuous charge distribution surface. Okay guys, up to this point we know only point charge. Okay, इधर charge linear क्या है, rod है, इसके ऊपर मान लो पॉजिटिव चार्ज है. Okay, now this is whole charge, I will call as an Q. This is not a point charge, right? We define the electric field intensity and the Coulomb force only for the point charge. Point charge means only small amount of charge hona chahiye, correct na? But here they given total charge Q, right? We need to find out now, due to this total charge, along the line joining point at a distance A, okay, here not mentioned, at a distance A, there is a point. Okay, on this point, or else mondo, this is also test charge Q0. On this point charge, how much amount of force is acting? Force only or electric field? Okay, electric field lines का value कितना है, electric field intensity का value कितना है इधर, we need to calculate. How to calculate this one? मान लो ये rod का length भी दे दिया है L. L is the total length of the rod. इधर एक टेस्ट चार्ज है, मीन्स मान लो what is happening here? Okay, this is a test charge, मान लो charge by surface area. Good Swati, try it. Okay, generally electric field intensity means क्या होता है, E is equal to, इसके ऊपर depend भी नहीं करता है, that's why if you are not writing also means it is good enough. Okay, K Q by R square, exactly right. But if you are writing this equation for the continuous charge distribution, especially this is a continuous, okay, continuous charge distribution करने के लिए ये expression लिखने से wrong होता है, ये expression गलत है, क्योंकि ना I told you only for the point charge it is valid, right? Point charge means this is a total charge, we need to take only a small amount of charge. What I will do, देखो इधर, I will take here a small amount of charge on the small length, I will call this one as an dx. ये dx के ऊपर कितना चार्ज लगता है, dq amount of charge होता है. हाँ, I didn't understand that one. Okay, dq चार्ज होता है dx लेंथ में, करेक्ट ना. इफ आई टेक one more dq element means here again here dq charges dx length में. Like this, these are all become point charges. Now for this point we can write okay, now dq charge is there means here creating electric field value will be de होता है, correct ना. Like this we need to add each and every segment of a charges throughout the length. L length है ना, इधर से इधर तक पूरा लेंथ का कट करके उधर de plus de होता है ना इलेक्ट्रिक फील्ड इंटेंसिटी, उसको कैलकुलेट करना है. After that we will get a total electric field strength when continuous charge distribution they given that time. Clear, right? Point what I'm saying. Is it clear what I'm saying? ನಾನು ಹೇಳ್ತಾ ಏನ್ ಹೇಳ್ತಾ ಇದೀನಿ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? If you feel it is not understanding means let me know. I will try my level best to reach out to you all. Yes, good, good. Okay, now देखो इधर d के लिए इक्वेशन लिखना है हमको. क्या होता है? d वैल्यू विल बी इक्वल टू k, एक q है ना, इसको रिप्लेस करके we need to write dq divided by dx है. ये dx will be at a place I will take x से है, x distance में है. That's why I will write here x square. I will call this equation number 1. I would like to call this equation number 1. Clear है ना? Now only we define like that, guys. Charge density, correct ना? Linear charge density के लिए lambda is equal to q by L था, correct ना? Okay, good. Now look at here. Only dq amount of charges are there in dx length में, correct ना? Then this equation can be written as here dq by dl. We will use this one. How to use this one and everything I will tell you. No worries. Okay, देखो इधर इक्वेशन उन्हें है ना, इक्वेशन उन्हें इधर d को इंटीग्रेट करना है, पूरा dq एलिमेंट का पूरा d आता है ना, उसको इंटीग्रेट करना है. That is it. Okay, directly I will come to the point. Now, okay, if you are going to integrate the d means you will get e मिलता है. And then now you need to integrate this part. Here k is constant and x value is continuously changing. You need to integrate this part only. Now x value will be up to here. For the second dq, x value will come here. Third dq, x value will be come here. Like that. Correct na? That's why take k outside. मैंने ले लिया. And then integrate करना है dq by x square here. Correct na? Is it possible to integrate at this situation? Let me know in a chat box. Is it possible to integrate this one? Now x 1 by x square को integrate कर सकते हैं क्या? Let me know. Everyone do participate here. You have to tell, everyone should be participate here, and you people have to tell me whether is it right, whether is it possible to integrate this term 1 by x square. No, no, no. Do you know why? Because here function is x square, correct ना? इसको integrate करना है means here we require dx, but here dq is there. That's why we can't able to integrate. For that reason only we need to take here this help. Linear charge density का help लेना है, correct ना? Right? देखो इधर. Sorry. Okay, q by L is the total charge per unit throughout the length. Q charges which are accumulated in a total length, which I am taking here dq amount of charge, they are accumulated in the length of dx either. Correct na? Here if you're going to write the equation for the dq, what will become? देखो dq will be equals to q by L, that is nothing but charge density into dx. Correct na? Now substitute this dq value in this equation, right? इक्वेशन 2 में सब्स्टिट्यूट करो, देन देखो इधर ई वैल्यू विल बी k इंटू इंटीग्रेशन ऑफ dq मीन्स q बाय l इंटू 1 बाय x स्क्वायर इंटू dx आ गया. Now you people can integrate this part 1 by x square because dx came, no, that's why. And most interesting fact is that from where to where we need to integrate, correct now? Before that I will tell you that one also. Before that guys, I will take this constant term to outside, then it will become kq by l integration of 1 by x square into dx. Correct now? Note down this formula. I will explain further. I will explain it. Note down this one first. I will further calculate this one in the next page. kq by l into 1 by x square into dx. देखो इधर. What is the equation we got? E value will be kq upon l integration of 1 by x square into dx. This integration from where to where it will be integrated, that one we need to write here. dq amount of charge, dx था, ये दोनों को बीच में distance मैंने दिया था ये, okay. From dx to this point distance था x and length of this rod will be l, correct ना? Now देखो from this point a point से last point means b point अब तक integrate करना है, then all the dq amount of charges will be added here, correct ना? Okay, then if we want to integrate means we need to integrate from this point itself, means ये है, ये से from this point to this point means again ये plus l, correct ना? ये total distance को integrate करना है, right? देखो इधर integration will be happens from a means from the point to the from where which point you are going to calculate, from that point onwards to last point till the end of the conductor means a plus l. Clear, right? How I took the limit? Is it clear guys how I took the limit? Good, thank you for responding. Okay, now integrate this one. फटाफट से इंटीग्रेट करना है kq by l, ये 1 by x स्क्वायर के लिए इंटीग्रेशन होता है -1 by x, ओके. लिमिट अप्लाई करना है a to a plus l, 1 by x स्क्वायर का इंटीग्रेशन -1 by x and limit will be a to a plus l. Now substitute the value kq by l into 1 by x means x का प्लेस में अपर लिमिट सब्स्टिट्यूट करना है and then lower limit में again x प्लेस में रिप्लेस करना है. First we'll substitute the upper limit, -1 by x means a plus l, again minus lower limit का बोलते हैं, minus lower limit means 1 by a. Clear, right? Good. Yes, good. Then next thing, kq divided by l into here if I am going to multiply the equation with the negative sign means what will happen? This okay, sorry, this is minus into minus, it will become plus here, sorry, this is a mistake. Okay, plus हो गया, ये दोनों को मैंने इंटरचेंज करके लिखता हूँ 1 by a minus 1 by a plus l, करेक्ट ना? ये दोनों का देन एलसीएम ले लो, एलसीएम लेने से kq by l into LCM will be a into a plus l. न्यूमरेटर में क्या होता है देखो, a plus l मल्टीप्लाई कर रहा हूं मैंने माइनस ये, दिस माइनस ए प्लस ए कैंसिल, नो, दिस l कैंसिल and remaining term will be here kq divided by a into a plus l. This is the electric field intensity which will be acting on this point P in this direction due to continuous charge distribution. Due to continuous charge distribution. Hope it is clear to everyone, right, guys? It took a lot of time. I will agree with this one. Okay. But बोलना था इसको क्योंकि ना the same kind of problem I solved in a gravitation. Okay, for that reason. Clear, right? Don't know, today the class will not went properly. Even I am also not yet satisfied with this one. Okay, tomorrow I will come up with a good energy again. Explain the step of applying limit. Okay, definitely I will. This step, no, I will explain this one in a new page. देख लो. क्या आ गया था हमको? KQ by L minus 1 by X after integration. Limit will be A to A plus L. Correct na? We will call this one as an upper limit. This is called the lower limit. Okay. Applying upper limit and lower limit है ना? When we are going to apply, we need to replace the function. Function के लिए replace करना है limits को. ठीक है ना? First we'll apply the upper limit. After then we're going to subtract that one and we'll apply the lower limit. That's it. Now KQ by L upper limit है, means 1 by extra place में upper limit substitute करना है. That's it. Upper limit means here A plus L होता है minus lower limit है. Lower limit means here 1 by minus X है, means minus of extra place में ये substitute करना है. Correct ना? This minus and this minus will become plus now. Clear? This is will become plus. Then next thing क्या है? इसको मैंने change करके लिखता हूँ. KQ upon L interchange. Sign will be same ही होता है, no? 1 by A minus 1 by A plus L. Clear? And later on, if you're going to take the LCM for these two things, क्या करना है? LCM ले लो. LCM लेने से KQ by L into here A into A plus L. Here remaining term, if you're going to multiply here, means on solving this one you will get A plus L minus A. Correct? Yeah, that's great. Okay, here A will be cancelled, and then next term will be KQ by L tha, either L divided by A plus L. L cancel, and finally KQ divided by either A miss हो गया, हाँ, A into A plus A. This is the final answer. Yes, that's great. Okay, guys, we'll meet in our next class. Okay, until then, take care. Bye everyone. Bye Sagar. Bye Niranjan. Thank you, bro. Okay, Purva. Bye. Bye. Shut.